Hello, AB and BC Calculus classes, who's ever watching. This is 2013, question number 5. This is a Region R question. AB Calculus students, Region R is not on your exam. BC Calculus students, it is on your exam. But either way, you need to know what's going on here. Okay? So we're going to go ahead and start with part A. And part A says find the area of R. Now, if this was a calculator question, it would be so easy. The area of R is simply top equation minus bottom equation. Now, how did I know this was the top and this was the bottom? Well, let's just start with this one. I just knew 2x squared is a parabola facing up. So I knew this one had to be the parabola facing up. You should know that cosine looks like this, and that cosine starts off at 0 way up here like this. But anyways, I just knew 2x squared would be facing up. So it's just top equation minus bottom equation. From 0 to 2. Now, this one question alone takes a ton of time, and we're going to deal with this piece off to the side. Okay? Before I start with this piece, let's look at the quick rule. The rule is the antiderivative of cosine u du is sine u plus c. So, we're just going to deal with this off to the side. Okay? So I'm going to go over here and say we have the 4. The 4 is not what I need, so I'm going to put the 4 off to the side. And I'm going to put here cosine of 1/4 pi x dx. Okay, I'm just dealing with this piece alone off to the side. And if I was going to have a u substitution, if u has to be here, that means my u needs to be 1/4 pi. Now the pi technically is on top, so 1/4 pi is actually pi over 4. So the u would be 1/4 pi x, and the derivative of that is just simply pi over 4. Think about it this way. If I had 8x, the derivative is simply 8. So 1/4 pi x, the derivative is just 1/4 pi, which I'm going to call pi over 4. So I need a pi over 4. I do not have a pi over 4. I have to put a pi over 4 offset by its reciprocal, 4 over pi. Now, if I do that, I'm basically done, because out in front I have 16 over pi, and this is now cosine u, and then these two are the du. So the antiderivative of cosine u du is simply sine u, and u again is pi over 4x. I'm calling it pi over 4 instead of 1/4. So the antiderivative of this is right here. Now the next piece, before I take the antiderivative, I don't like having this negative belonging to everything, so I'm going to distribute it to everything. So if I distribute it, it's going to make this piece a negative, this one a positive, and this piece a negative. Okay, it's just what I prefer. And now I'm going to take the antiderivative. So I add 1 to the exponent and divide. I go on to the next piece, I add 1 to the exponent and divide. When I divide 6 by 2, I get 3. And here I take the antiderivative. From here, I need to plug in a 2 and a 0 and subtract. Now, a couple of things are going to show up in this problem. In the middle of this problem, we're going to need to know what is sine of 0 and what is sine of pi over 2. So just very, very quickly, at 0, we have 1 comma 0. Remember, this is cosine and sine. So when we see sine of 0 in the problem, sine of 0 is 0. At pi over 2, we have the ordered pair of 0 comma 1. And again, it's cosine sine. So when we run into sine of pi over 2, I need 1. Okay, so I first plug in a 2. When I put a 2 here, I'm going to get 2 pi over 4, which is going to be pi over 2. So I put a 2 here, again 2 over 4 becomes pi over 2. I put a 2 here. I put a 2 here. I put a 2 here. Minus. Now watch the beauty of the next piece. When I put a 0 here, I will end up having a sine of 0, which is 0. I know there's something in front, but it's 0. I put a 0 here at 0, a 0 here at 0, a 0 here. Because sine of 0 is 0, that piece is 0, that piece is 0, that piece is 0. This is all just one big 0. All right, almost done. So this is 16 over pi. Sine of pi over 2, we already talked about, is 1. And I'm not simplifying any of this other crap. If you simplify and you mess up, you lose points. So that is how I'm leaving my answer. Yeah, it looks pretty to me. All right, that's part A. Now let's go to part B. Part B and part C are going to go really quick. We don't have a calculator in this question. Not having a calculator is a blessing. You set it up, you walk away, you don't have to type it in. So it maybe doesn't seem as great, but it's going to be good. All right, so let's go ahead and do the second question. It says, write but do not evaluate what we get when we rotate this around y equals 4. So part B, and here's my line, y equals 4. When I rotate around y equals 4, there's going to be all this open gap, which means we're going to have what's called a washer. So if this is a washer, the washer formula is pi outer radius squared minus inner radius squared dx. And it's going to go from 0 to 2. All right, so we need the outer and the inner radius. So let's just go ahead and draw the outer radius. The further one away is the outer radius, and the closer one is the inner. So let's talk about the outer radius. The outer radius, this distance right here, this is my outer radius. We would say it's top equation minus bottom. So it's top equation 4 minus, and that bottom equation better be in parentheses, so it's 4 minus this other equation in parentheses. Now, if you like hotkeys, or if you like substitute, just use f of x there. I could have just as easily called this 4 minus f of x squared. Would have made a lot of sense. And then my inner radius, again, top minus bottom, so it's 4 minus this equation. So it's 4 minus, and then here we have 4 cosine 1/4 pi x squared. So again, that's outer radius squared minus inner radius squared. You could have put a g of x there instead. And that's it, because they just want you to set it up. All right. The final part's going to be making cross sections that are squares. All right. So part C. So what we're going to be doing is we are going to be making cross sections that come out as squares, meaning little square coming out, medium-sized square, big square coming out, little squares. So we're going to have squares coming out towards you. We're building squares out that are perpendicular to the x-axis. So this is perpendicular to the x-axis. There you go. And we're going to pretend like this is made out of cheese. So we're going to chop, 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 chop. And then we're going to reach and we're going to grab one of those little slices, one of those cross sections. And they're all squares, so it's going to look like this. And if this distance is s, because it's a square, this is s, and the area is s squared. So the area is s squared, and s is simply top equation minus bottom. Now, top equation, 4 cosine 1/4 pi x, that's top equation minus bottom equation, and the bottom equation is all of this. So that's top equation minus bottom, so that's s, and we need s squared, so s squared. What you could have done for s, it would have been even easier. For s squared, s is top equation minus bottom. I could have just did g of x minus f of x. That looks easier. But I wrote out the equation for g of x and f of x. And again, now I need to add all of the squares up. So chop, 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 and you add them all up with the integral, starting at 0, going all the way to 2 dx, and there you go. They didn't want you to finish it. They said just write the equation, or the integral. So this would obviously be easier, g of x minus f of x, or you could just write the whole equations out. But if you write the equations out, the second one has to be in parentheses. All right, that's part C. That's cross sections that are squares. Hope you enjoyed the video. Have a good weekend. Bye.